JEE Advanced 2021, Paper 1, Question 12. Physics, Refraction and Total Internal Reflection. Let us visualize the setup. We have a wide slab consisting of two media. The bottom layer has refractive index N1, and the top layer has refractive index N2. Above the slab is air with refractive index 1. A light ray travels from medium N1 towards the N1-N2 interface, making an angle theta with the normal, where sin theta is slightly larger than 1 over N1. The question asks, which statements are correct? Option A, the light ray enters air if N2 equals N1. Option B, the light is finally reflected back into N1 if N2 is less than N1. Option C, the light is finally reflected back into N1 if N2 is greater than N1. Option D, the light is finally reflected back into N1 if N2 equals 1. The key concepts are Snell's law and total internal reflection. Snell's law states N1 sin theta 1 equals N2 sin theta 2. Total internal reflection occurs when light travels from a denser to a rarer medium and the angle of incidence exceeds the critical angle, given by sin of critical angle equals N rarer over N denser. The crucial given condition here is that sin theta is slightly greater than 1 over N1. This means the ray is just beyond the critical angle for the N1 to air interface. Step 1, the key condition. Since sin theta is greater than 1 over N1, multiplying both sides by N1 gives us N1 sin theta greater than 1. This is crucial. By Snell's law, at any boundary with air, N sin theta prime must equal sin theta air. If N sin theta prime exceeds 1, then sin theta air would exceed 1, which is impossible. This means total internal reflection occurs at any interface with air. Step 2, checking option A where N2 equals N1. If both media have the same refractive index, the light passes through without refraction. At the N2 to air boundary, N2 sin theta equals N1 sin theta, which is greater than 1. So total internal reflection occurs at the air boundary. The light does not enter air. Option A is incorrect. Step 3, option B, where N2 is less than N1 but greater than 1. At the N1 to N2 interface, the critical angle has sin equal to N2 over N1. Since N2 is greater than 1, the critical angle sin N2 over N1 is greater than 1 over N1. Since sin theta is only slightly greater than 1 over N1, it is less than N2 over N1. So the light enters N2. But at the N2 to air boundary, by Snell's law, N2 sin theta 2 equals N1 sin theta, which is greater than 1. So total internal reflection occurs, and the light reflects back into N1. Option B is correct. Step 4, option C, where N2 is greater than N1. The light goes from N1 to a denser medium N2. No total internal reflection is possible at this interface, so the light enters N2. Inside N2, sin theta 2 equals N1 over N2 times sin theta, which is less than sin theta. The ray bends towards the normal. But at the N2 to air boundary, N2 sin theta 2 equals N1 sin theta, which is still greater than 1. So again, total internal reflection occurs at the air boundary. The light reflects back through N2 into N1. Option C is also correct. Step 5, option D, where N2 equals 1, meaning the second medium is air. At the N1 to N2 interface, the critical angle has sin theta C equal to 1 over N1. But sin theta is greater than 1 over N1, so theta exceeds the critical angle. Total internal reflection occurs right at the first interface. The light never enters the second medium. It is reflected back into N1 directly. Option D is correct. The correct answers are options B, C, and D. Option A is incorrect because even when N2 equals N1, total internal reflection occurs at the air boundary. Options B and C are correct. The light enters N2 but undergoes TIR at the N2 to air boundary in both cases. Option D is correct. When N2 is 1, TIR occurs at the very first interface. The unifying principle is that N1 sin theta exceeds 1, guaranteeing TIR at any boundary with air. Exam tips for JEE Advanced. Tip 1. Always track the product N sin theta through every layer. Snell's law preserves this quantity at each boundary. Tip 2. If N1 sin theta exceeds 1, total internal reflection at any air boundary is guaranteed, regardless of intermediate layers. Tip 3. TIR at a denser to rarer interface requires sin theta greater than N rarer over N denser. Tip 4. Light going towards a denser medium can never undergo total internal reflection at that interface. Remember these key formulae for refraction problems. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.